Thank you all. Yeah, so we'll move right into our next session. We have a session on the lifelong learning panel, which is going to be led by Dave Poloian. He is from Microchip, and we have a panelist from Altium, Infineon, and Tektronix. But we'll go ahead and turn it over to Dave at this point.
Hey, hello, everybody. And thank you, Mario, for the great segue into this topic. My name is Dave Poloian. I'm from Microchip. I head up the academic program there. And I've spent about 40 years in the semiconductor industry. Most of that has been involved in technical learning and knowledge management. So I was asked to facilitate today. I'm going to be joined by Judy, Mark, and Wilson, and they'll be joining the discussion. Originally, when we started kicking around the ideas for this session, it was going to be focused primarily on the results of the pandemic and how that affected virtual learning. But as the group started their discussion and got more under the hood, we broadened it out, kind of acknowledging, as everybody's just been saying, that lifelong learning is a critical skill, and we want to make sure that as educators we can get that skill embedded into the curriculum. And so what we'd like to do today is, from a corporate perspective, go over a couple of major topics. I'm going to share a screen real quick. Can you unshare, Kim? Okay, let me try to get that up. So the two main areas that we're going to be discussing are in terms of lifelong learning. We do have, as corporations, some expectations of students coming in terms of as new hires, that they will have ownership in their own personal development, and so there are going to be a lot of attitudes that we expect them to have with regard to learning and self-knowledge. And so that's going to be one of the primary focuses, is what the companies are expecting of engineers that are coming into the workforce. And then also, we want to give you a little bit of an idea of the kinds of things that the companies are doing to allow or to enable engineers to keep current. What kinds of technologies, what kinds of tools that are out there, so that you can prepare your students to be ready for those and to take advantage of those when they get into the workforce. So we're going to start the discussion with the expectations and what we expect from students. So what I'm calling these are attitudes. We want students to understand what they don't know, so that they know that they have to learn something. We're also seeing a lot of things in the incoming crop of students that they tend to do a quick look up in Google of something, and they get that first answer, and then that's it. We're thinking we need to go beyond that. And then also, once they do pick up some new information, how do they take that information, apply it, get some experience with it, and actually develop some knowledge? So let me first introduce the panel. I'll let each one give us a little bit of a discussion on who they are, and then we'll go right into that first topic. So, Judy?
Good morning, everyone. My name is Judy Warner. I'm the Director of Community and Industry Engagement at Altium. I'm now part of a new business unit here at Altium called Nexar, which is why you see that up in the corner of my slide. And my job here at Altium, I've been working 25 years with design engineers, and my role here at Altium is sort of, I think of it as bridge building between Altium users, design engineers, and I come from the manufacturing industry, from PCB manufacturing, assembly, and so I see myself as a bridge builder between students, our users, and also the industry, and help kind of creating and identifying those places of connections between those people. So I'm really glad to join this panel today and share some of our learnings.
Thanks, Judy. And then Mark.
Hi, Dave. Hi, everybody. Yeah, I'm Mark Finn. I work at Infineon, and I've been in the industry for 26 short years now. I think I spend a lot of my time with I run applications engineering, so I spend a lot of my time with understanding customers' problems and trying to ramp up engineers to understand customers' problems as quickly as possible so that they can be effective and so that they can be effective in the business. So we go from student interns to up and running plug and play engineers as quickly as possible. I think that's what we're looking for in our organization. So I spend a lot of time structurally making sure that we can do that. The next engineer who can come in is going to be good for the company, and understanding how that works both individually and institutionally takes up a lot of my time. So I'm delighted to talk about this topic today.
Great. And then Wilson.
Good day, everyone. It's a great honor to be on the panel. My name is Wilson Lee. I'm the Education Market Segment Lead at Tektronix. At a summary level, that is not only providing hardware and software solutions that are used in teaching labs, but I think as a window to CETA is really building partnerships in ecosystems, of which this summit and session is critically important. While being at Tektronix for about 5 years, previous to that, roughly about 25 years in various industries and technical marketing sales. So I'm hoping that the discussion at large will help spur, I guess, what I would say is the bridge from the great session this morning to what is practiced and expected in industry. So thank you.
Thanks, Wilson. And let's start the discussion with you. Again, our first big topic is going to be what companies are expecting of students coming in. So if you can give us a little insight as to what your hiring managers are seeing and what they're looking for when they hire a new engineer with regard to in regards to lifelong learning.
Yes, so I think at a high level, particularly over the last year of the pandemic, a lot of what the recruiting envelope looks like are actually the softer EQ side of candidates that are available. By that I mean, it's not strictly the function of an engineering discipline, whether it's computer or electrical engineering, but it's the inquisitiveness, it's the willing to take some risk and work in ambiguity. I think there's a great element of cross-functionality. So I think in the previous sessions, kind of the need of not necessarily just one engineering discipline, but multiple. And there's a great element of customer exposure. That being able to, again, be active in terms of engaging, whether it's internal or external customers, to really understand the perspective or the workflow or the pain points. And that's overdriven, putting the pandemic aside, in some of the industry megatrends that we're seeing, whether it's in advanced wireless or quantum computing, et cetera. I think what we're seeing is actually what I would call a candidate pool that's in flux. So I think particularly in the last year, there's been a much wider diversity in the talent pool. So changing somewhat from what I would say is kind of a core discipline in one engineering discipline. We've also been seeing a lot of non-engineering candidates who show the aptitude to learn on the job. I'll pause there and hand the mic back to the floor, Dave.
Okay, thanks, Wilson. Mark, how about you from your perspective at Infineon? What are you guys seeing, and what are your expectations of the new hires?
I think Wilson hit a lot of nails on the head there, so I'm not going to repeat what he said. Mario made a very good, I think it was Mario made a very good point earlier on, just about we don't expect you to be job trained when you come in, right? You've got a third level education. That's what you've done in college. We don't expect job training, but we do expect you to be able to learn. And we look for that in terms of finding people with independent learning efforts, right? They've gone outside what you would see as the standard issue, and they've created projects, or they've done their own kit, set something up, and made something work with both hardware and software. And that's generally what can differentiate people in the market at the moment. As Wilson said as well, it's a broader skill set. It's, traditionally silicon was, I understand gate oxide, I understand what's happening in the transistor. Now it's, I don't really care what your transistor is doing, will it run my software? And having an understanding of both of those is what we're looking for in the industry at the moment. Obviously, we will look for expertise on all of those areas as well, device physics or software specifically. But when we're going into a broader range of applications engineering or customer focus, as Wilson said, then we're looking for a little bit of rounding. And again, the expectation of somebody coming out of third level education is not that they're job trained. We will help you with your job training. You need to be somebody who will roll up your sleeves and willing to troubleshoot and willing to make the effort and look around and find things in the industry that make sense to you. And that's really what we're looking for most of the time.
Okay, and then Judy, how things at Altium?
Well, here at Altium, obviously we're a software-based company for PCB design. However, for my role, I get to kind of have this broad look across the industry, kind of end-to-end supply chain up and downstream from, our core customers or our employees. And something I'm observing, particularly with students, is we've covered a lot of student teams, right? Engineering teams, so Hyperloop teams, solar car teams, things like that. And we're seeing a trend in that there's a disconnect in that 80% of Altium's customer base are EEs. However, when they enter the industry, other than a capstone project, they're not prepared to lay out PCBs. And there seems to be a disconnect between, any kind of, heavier duty exposure, unless they go up into upper, master's or PhD, they may get more exposure there. And then industry is sort of has an unspoken expectation, like, we'll just go design a board. So there seems to be, as far as I can tell, this rift. But the kids that seem to be getting picked up for all the reasons that both Mark and Wilson, sort of this go get them, go find the information, go source it, seems to come out of the experience that students have either on student teams or external projects or design competitions where they are, participating in some kind of massive onboarding of software, hardware, the systems-based thinking or the cross-functional thing that you've all been discussing. And so something we try to serve up, and resource is to kind of build that bridge between highlighting things for students, say with IPC, where there's student chapters, or we're engaged with Arduino. So can you, start bringing up a project on an Arduino board and just, and then these competitions and things, and it seems to equip and cover the some of the things that are not going to be covered through their curricula at a university, but it at least gives them a taste, right, of those things, because we are noticing that when these engineers, what they think their job's going to be like and what their job is actually like are two different things. And that sometimes they'll end up going into a conference room, and other experienced engineers say they go into a project meeting, and all the young engineers feel like they're the only ones in the room that don't know everything, like that they just missed it. So there's sort of this imposter syndrome that can impede them from knowing, like Mark said, we'll train you, but how do we communicate that bridge between university and students and saying, you don't have to know everything, just you have to know where to go to get those pieces and pick them up and quickly and communicate that lifelong learning. I know people that have been in this industry 30, 40 years, and every single one that has any kind of notoriety has said their secret to success is lifelong learning, and that it belongs to them personally. They don't look for their companies or their universities or anything else. They give it to them. How do they take ownership of that lifelong learning? And then how do they find those bridge points to go on board that information?
Very good. Yeah, the question or the comments you made about these immersive programs, I've been a mentor for FIRST Robotics for high school kids for the last, I don't know, 20 years now. And yeah, there's something about the whole idea of having a deadline, a group of people trying to solve a problem together, and just being immersed in that, that does a number of things. First of all, it forces the learning. And since you have to actually accomplish something, it's got to be learning at a depth where you can apply the knowledge, not just superficial fact knowledge. Plus, they're working with other students, so they learn how to collaborate and learn together. So yeah, those kinds of programs are huge, and anything we can do to kind of replicate that dynamic in the curriculum would be great.
A couple of years ago, when they first launched the Lab program on the back of what you're saying, Dave, I had a little 10-minute piece that I got to join and actually speak to that group. And what I was suggesting, and I don't have the answer here, but I'm like, what can we do in the labs as we return to classroom this year? What can we do in labs? Because that immersive learning is precisely like real world engineering, right? There's a deadline, there's a budget, there's known constraints and some unknown constraints, and you're just thrown into the deep end of the ocean. So how can we create those perhaps in a lab or design competitions in the university? So those are just some things I'm thinking about, and I would love to be part of or support.
Very good. And before we move on to the next topic about tools and things, one of the topics we discussed when we were prepping for the session was this idea that in school you learn not to cheat, and sometimes that might impede your ability to collaborate. So maybe anybody on the panel would like to jump in and make a few comments on that.
Yeah, I have a few comments on that one because that one is very close to my heart, Dave. Yes, plagiarism obviously is a very bad thing when you're doing when you're in school. In our industry, at least within the company, let's not talk about plagiarism across companies, which is maybe espionage, but within the company, you have an obligation to use what's been learned already. You are literally wasting the company's money if you're relearning something that someone has already learned in the corporation. So you have an obligation to learn from the others who have learned. And the flip side to that, you have an obligation to write down what you learned so that those people can learn from you. And this is institutional corporate learning, right? This is how you become the best in a cutting edge industry. If you want to stay ahead of your competitors, you cannot relearn things in 4 different departments of your same company. That is absolutely ridiculous. It is a waste of time. It is a waste of effort. It's a waste of money. So sharing your learning across the organization is very, very important. And that goes both ways. You learn from others and you provide for others. And my expectation would be, as an engineer, you would be learning something decent every 2 weeks in your job, right? You would be discovering something new that's useful to another engineer who's not you every couple of weeks, and sharing that piece of information, writing it down, putting it in a place where it can be read. Even if you've left the company in 4 years, or 10 years or whatever, it's written down there and somebody else will use it. So it's very important that in industry that we're not reinventing the wheel every 6 weeks in different geographies for multinational companies, and that we are providing and that we are extracting from that database to make sure that we're bringing the industry forward.
Good points.
Yeah, I think I would add to Mark's comments that at least in the vein of plagiarism is a form of a complement, non-espionage point of view, that engineering is a very scarce resource. So one of the legs or pillars in terms of ongoing learning at Tektronix is this notion of sprints, whether it's trying to continuously improve, make something very good even better, or problem solve to some X target. But there is this treasure trove of design measurement or otherwise unlocking insight that comes from ideas previously done and ideas that may have actually so-called been killed previously. I think it also unearths the need and the notion around a collaboration, whether it's synchronous or asynchronous, which actually in the last 12 months through the pandemic, I think industry at large, but of course in the perspective of Tektronix, has really required us to I guess, look at how to repurpose certain ideas in a way to move at pace into the ambiguity of the pandemic.
Very good. Okay, I'm going to bring our slide up again real quick. So that we were talking mainly about, the attitudes there that we're expecting of the engineers coming in, and now we're going to move on to the kinds of things that companies are doing to support lifelong learning and personal development in their engineering community. And this is not only for the new hires, but in general, what kind of a learning environment should the engineers that are coming into the workforce expect? And so our discussion here is going to have a number of dimensions. There's, of course, there's a structured kind of learning that you have, instructional material that's developed in academies and those sorts of things that you have in your company. But there's also this idea of providing environments that allow them to explore, to look for answers, both inside and outside of the company. And of course, and we've already talked a little bit about this, but let's talk about it from a tools perspective, the idea of learning from others, collaboration, mentoring, and those sort of things. So maybe Judy, can you kick off your discussion there on what kind of resources Altium provides to engineers that allow them to continue developing their career and skill levels?
Yeah, I could talk a long time with that, but I promise I'll try to keep it brief. The reason I chose to put up this Nexar slide isn't as a, to trick or whatever. It's that I wanted to highlight that one of the ways, it's actually a trend in technology at large, but I think a lot of us have seen, particularly during the pandemic, sort of a drive to the cloud, right? And virtual learning environments. And so the business unit that I'm now part of is called Nexar. Nexar is a cloud-based environment, and my job specifically around that is to build an ecosystem in which there can be self-serving things happening. We're not being prescriptive. What we're trying to do is put in that ecosystem design professionals, but also supply chain professionals and manufacturers and software tools and simulation tools and power integrity tool experts, and sort of be sort of the watering hole, right, for the whole tribe. And we've observed through in-person events that if we just put all these people in the same room, they sort of create this synergy and natural things happen. Natural mentor-mentee relationships form between older and younger people. And so we're continuing to do that at in-person, but I think that as the whole industry pushes toward the cloud, and particularly that's accelerated during COVID, I think pushing some of those experience for collaboration or connection or meeting and sort of this hybrid approach, right, between in-person mentor-mentee relationships and cloud-based communities, right? And so, you see this sort of cropping up in different places right now, all across the industry. And it's a thing that other segments of the market have already done. For whatever reason, technology seems to be lagging, but that got accelerated during COVID. And like I said, I don't have the answer. I think the answer is that we just set the table, right, to where those things can happen organically. And I think that we don't know exactly what that will serve up. And then also personally, as I communicate to students, to our customers, and to industry professionals, you know, I think to also raise awareness of things like IPC student chapters, which can raise awareness. You know, I think trade associations involvement. I think volunteering. I mean, I think everyone can relate, especially, you know, so people that are participating as contributors. Whenever you join something, it seems like, oh, I'm adding something else to my plate. But I think we all have had that experience as, wow, I made some really great connections. And that one connection changed my trajectory. I onboarded something really important. And, you know, that's not easy to quantify, to put in an ROI or things. But I think most of us that have been around the block for a while know that that's some of the most valuable relationships and things that we can build to drive, you know, from students into industry, or industry into expertise, or, you know, whatever that is. So I also think trade associations, there's some, particularly for designers, PCEA, which is the Printed Circuit Engineering Association. I've been part of their executive board, and bridging students with these experts that are dying to hand off all their knowledge. You know, it's not collected in some central knowledge-based library that young engineers can go to. But I think industry associations, I think clubs, I think student chapters, I think this is all things that I enjoy being part of. And we're serving up sort of on a scalable model and sort of at a more grassroots level. And again, not easily quantifiable, but I think undeniably valuable.
Great. And Wilson, what does the toolbox look like at Tektronix?
Yeah, so I'll share some of the key themes. Pretty much any corporate entity, we do have a core of kind of our learning center, which on one level is prescriptive, so it pushes certain prerequisites, particularly depending on the function within the company. But there is this element of self-serve. So I think that particularly important, even veterans that we've had in our company for 20 plus years, is that notion of kind of learning on the side in the evening. And I think that's becoming more and more important, particularly as students come into industry. I think based on their behavior, particularly the last 12 months, of kind of liking that asynchronous environment to kind of consume and widen one's horizon. A very important part of kind of the enablement is really this, I'll call it programmatic. So whether they're design sprints, we may call them Kaizens, kind of the continuous improvements, and other flavors of that to drive innovation. Really try to immerse both incoming employees from university or even veterans around that cross-functionality, whether it's program managing at a high level, whether it's learning electrical if you're a computing engineer, but also the ability to understand how to allocate so-called design trade-offs in a way that's, again, tied to that immersion with customers. So really the interaction with either internal or external customers, from really eloquating how it works for them, but in such a way that it's data-driven. And I think at the end of the day, really driving that active listening, which we kind of covered in the first set of questions. I think the last is kind in kind of phases. It finds it in the form of either job rotation and that mentorship. Certainly Judy touched on this point. Some of it in great part is formal mentor relationships, but I think given the stack of these different elements drives that informal mentorship. And it's interesting, in some ways, the informal mentorship it can be more powerful than the formal one. Because mentorship is actually quite a learned skill. And sometimes even the best functional veteran in engineering may struggle with under the formality of a mentorship. And we've also found that actually even the veterans are learning from that informal back and forth, right, with some of the onboarding engineers. I think I would add one last dimension. Well, it's kind of informal, but in the form of either collaborative boards of sharing, so Yammer or Teams or what have you, but also this growing, I'll call it trend and need for groups. I think the last session covered that in terms of enabling those newly minted employees to feel included on all dimensions. But as an employee also to build up that confidence. So some affinitization is important. And so we've actually dramatically grown the number of employee resource groups. Some of them are very highly targeted, like Women in Technology or Black Excellence Matters. So I think holistically, the expectation I think is well founded in this session, which is lifelong learning. Ultimately, we're hoping that the tools that we put in place help apply the learning. So I think to your opening, Dave, let's go a little bit deeper, right? What are the multiple whys of a topic or a problem, et cetera? And I think the notion of what was covered in the first session around finding ways either on campus, remote, or otherwise hybrid in terms of the experiential learning. Some of it is debugging and troubleshooting, but some of it may be cross-discipline, like non-engineering types of learning to kind of bring it all together.
Very good. And Mark, talk a little bit about what's going on there at Infineon.
Yeah, I guess two elements. One is the internal one, if you're inside the company, and then how we bridge to maybe all of you as universities. Internally, Infineon is blessed with a very nice academy, very well staffed. It's global, so we consider not just what people learn, but the language they want to learn in as well, because we're a very global organization. So perhaps we were ahead of being ready for the pandemic because we had to educate people all the time online in the cloud, besides the in-person. I think what we had to overcome then was how they can get hands-on when they're not in an office. So how do we ship them a kit, something like this, and they can plug it in and start working with it and do some education that way. So we've adjusted that a little bit. The academy itself is set up really well in terms of the depth that you want or need to learn. For some jobs, you just need to get this deep, and for other jobs, you need to get that deep, and we striated it so you can just take the piece you need. Judy mentioned in one of her first comments that the expectation is that you become the lifelong learner. We set up this academy. There's great content in it, but you own your own career. You own your own path in life here. And as a student, when you come into the company, sometimes people have to be told this directly, and sometimes people just know it. But the expectation is that if you want to move on in your career, you take charge of that education, right? I'm not going to push it on you. I will make all the great stuff available to you. You come into the company, you take charge of that education, and there's a lot of stuff you can learn there. The internships and the mentorships and all of that we touched on already. But that's all provided. But unless you really take advantage of it, you're not going to get the full benefit. I think externally and in terms of the bridge to the universities, one that has struck me recently is communities. So we have, it was kind of touched on, but communities And what I'm talking about is, support communities, right? Forums where we will have people from all over the world asking questions about a product or about a system that we run. Doesn't really matter what company. This community exists for a lot of companies. But how did you get this done? How did you connect A to B? I'm struggling with this. And when I'm this, I guess for the department heads specifically, when I'm interviewing engineers who have been on my community and asked questions and answered questions and showed some interest, they could be doing it on multiple communities. They can show me other places they've done it, where they've gone to use our microcontroller maybe, and they've solved a problem, or they've not solved any problem, but they've gone there and asked questions and gleaned some new information. That's a big deal for me. I get a lot of resumes, but a resume where somebody says that they've actually contributed to my community, that's going to pique my interest a lot, right? And we came from Cypress Semiconductor to Infineon. That was a big thing in Cyprus also. And the community is a way for students to get involved with industry with no repercussions, right? You don't have to be a genius in that community. You just have to read, learn what's going on, ask some good questions, and answer to the best of your ability. And there are two levels of communities, so just be aware. There's the community where my watch broke, and the next guy says his watch broke too, and everybody says their watch broke, and they're theorizing. And then there's a community that's a little more moderated and professional, where three people say their watch broke, and people start talking about the solutions, and somebody within the company says, this is how you actually fix it, or thank you for your answer, you're almost correct, and here's the rest of it. So those are the kind of communities where you truly will learn. You're not floating around in the muck trying to figure out what's going on, but you're trying to give an answer, and then you'll get help to get that answer a little stage further. So that's a way for students absolutely to get involved with multinational corporations. If you want to get support, if you're doing a final year project and you want to get support from a huge global organization, you're probably not going to get that unless you're ordering multiple products. But if you're on their community, absolutely, they will have engineers who are at the same level as the ones who are helping the multi-billion-dollar corporations. And those engineers will be delighted to see you contribute to the community, because the same question you have, there are 100 other people with that question as well. So answering those questions, getting involved there is a way to start bridging that gap before you're ever employed.
Yeah, great points. In the opening, when we were talking about the skills or the attitudes that we're expecting of the students, one of the things is, as they dig deeper into solutions, being able to differentiate a good source of a solution from a bad source of a solution. Again, there's a lot of skill involved in navigating the muck, as you say. And so I know a lot of companies are starting to look into ways of gamifying some of those environments, or adding badges to those environments. And these are concepts that a lot of the students encounter, elsewhere, in their gaming life. But when you start applying it to learning, they have a kind of a guidepost to be able to say, all right, I'm really looking for somebody that knows this. What are the indicators that I have? And so I know a lot of companies are working on those areas. Have any of you folks looked into that in your corporate environments?
Yeah, absolutely, we do. I mean, we gamify all the time, and it is something that we spend a lot of time on. People in general who are in these communities, they look for exactly what you just explained: recognition and helping their peers and becoming a little more revered in the community. They're not looking for money. They're not looking for shirts and things like that. They're looking for what's the newest information on this product, or what's the new kit that's coming out, or how can I understand what's happening next. And it's great to give them that reward, because they just continue answering and asking questions on the newest thing as soon as they get it. And the scales are a little arbitrary for gamification. Obviously, Ken, I saw your point on there too. So one company to the next, it's going to be arbitrary, but there's still a scale, right? So you got to level 1, 2, 3, 4, 5. Obviously, if you see employee, that's somebody that you're going to respect, because that person is speaking on behalf of the company. But anybody outside the company who steps up levels within the community is very well revered, and you'll see them get a lot of gratitude and a lot of recognition, and a place to share their opinion on a very regular basis.
I would agree with that. I think there's currently in practice, but maybe a notion of, I guess, the super users, et cetera. We have I would call a tangential path to those who are really contributing at a high level, taking their own time, kind of mentoring back kind of into the community, that it actually can positively impact kind of their overall performance in a year, or kind of in the role basis. And I think that the two actually, while it is an emerging notion, I think go well together, because I think on the one hand, kind of just the wanting to contribute is one thing, but to give the employee or the student kind of that visceral feedback, kind of the feedback loop, I think is useful to consider.
Very good.
I would add on to that, that, you know, like Tektronix and like Infineon, Altium's building out an academy. I've sort of been interacting with the academic community as one of a few buckets that I oversee here, but now we're taking that on in a more formal way, and we're definitely gonna gamify it and do badges, but we really want to do also proctored tests. So it actually speaks to proficiency. So it's a little more solid. And we would like those things to, as students graduate, to mean something, to help them get jobs that indicate they have some level of proficiency, as well as make it fun and engaging and sort of give merit inside of our community. Something that we've been doing for a long time, which both Wilson and Mark have talked about, is sort of, it creates this bilateral feedback loop, you know, in that when someone comes on one of our forums, for example, if they're doing a terrific job of sort of naturally taking upon themselves the form of a mentor, or they're teaching real things, often our R&D team and our developers will invite them in and say, you know, we would like you to be an alpha or a beta user and help us understand your process, which in turn helps us develop tools that are more intuitive, that are in line with real world engineering and processes. So it does create sort of this complete feedback loop. And like Marcus said, we often pull those gems right out of our forums when we see they're taking that mantle of just sort of natural tenacity and contribution that they seem to be prone to. And I think this is something I don't know, it's just something I wonder about, is that, you know, I've talked to countless engineers. One of my jobs here is to host a podcast called On Track Podcast. And not every time, but many times I've asked young, you know, mid-level or high-end engineers, you know, at what age did you know you're going to be an engineer? And it's 5, 6, 7, when they found something that was broken that they were fixing. And what drove that? Curiosity, curiosity, curiosity. And I think as educators, we have to be careful that in the rigor of all the theory that they have to know the laws of physics and theory, they have to know that, but we don't turn them into passive learners, right? That we help them hang on to that curiosity, right? That's going to drive them forward in that lifelong learning path, right? And again, don't have the answer for it. I'm not involved in academia, so I don't know exactly what that looks like, but I think it's something worth looking at, and then pointing them at things. There's also external forums like Stack Exchange is something I just learned about recently, where you can learn about Python, or you can learn about designing an Altium Designer. So I think Stack Exchange is an external, you know, brand agnostic place. And I think that it would help for universities, professors, and department chairs to identify some of these areas to bring awareness to forums, whether they're, in companies like Infineon, Tektronix, or Altium, but also there's external ones that are extremely valuable that are online where a lot of learning can take place. So.
Very good. I think this might be a good time to open up questions. If anybody has questions of the panel, or if some of the comments that were made sparked an idea or something that you're doing in the classroom that you might want to share, this is a good time for that. Otherwise, I'm going to start talking about microchip.
I see Sid. So Sid's raising his hand. Sid.
Oh, hi. Hi, Judy. Thanks for noticing. A huge shout out to everybody on the panel. Nice to see you all. And thanks for bringing this topic. And Judy, you're right. The labs are probably the right stepping stone for students to enter the world. But I think until the pandemic, I don't think we were challenged to think of lab outside the brick and mortar. We were always physical. That was always focused on what we do inside the lab. And the urgency of replicating that same model when there is no physical space, I think allowed everybody to think of many ways. And I think if you ask universities, lots of folks innovated in how they distributed the content. But one thing that I saw this time, which was invaluable, which I didn't have, none of us most likely had, is what's out there in the online world of learning on their own. Lifelong learning and self-learning are so connected. The YouTubes and the edX and Coursera, really, I think it replaced a classroom. I think a classroom or a lab becomes the single point of contact for learning. There is one person who knows more, there's a TA who knows more, or the faculty who knows more. Now the students are going to look at 4 different sources to learn. And I think that's fantastic, right? Like, to learn Python, I don't have to be limited by the instructor in my school. And we have a class that tries to teach Altium, and it takes a lot of time to learn Altium and to master it and to make design ready for manufacturing design. But now there is so much on the internet that people can look up, read and not read, just look at videos. So I think we can certainly do better. And I think the labs will never be the same. I'm hoping that, at some point we get input from the industry to get the best practices to make our students self-learners. And once they become that, I think lifelong learning becomes an easier problem to solve. But thanks so much. Great panel.
Very good.
Alan, I think.
So I was just going to follow on with what Sid said. Finding the information that you're looking for. Most people just turn to the internet, and it's a wonderful source. But what I've noticed is the students are not like I was when I was a student, which was really before the internet. And they don't just go into the library and look at books and see how something was explained there. And they're looking for a quick answer, and understanding isn't quick. It just requires reading. And so I would like to encourage more of our students to enter this building we call the library, but they don't seem to be able to find it on campus.
Well, to your point, I think, Alan, that's a really good point, is there's a lot of bad information that's prolific on the internet. And because I've been, I had some tenure here at Altium, I see what companies can do to tweak the Google algorithms to make their content get to page 1. And it may or may not be the best information. Right? So I think that if we can somehow, one thing I took is someone I found in the industry that's an expert. I said, give me your 10 top books. And I shared that with our community because they had a lot of regard for this person. And they were deep and some of them are old books, but they've stood the test of time. And I noticed some of the experts in our space cite the same authors in the same book. So I think if we can somehow serve up maybe to university or to your students in some way, like a good solid reading list that would be accepted as, you know.
Yeah. And one of the things we've done at Microchip, we've got an annual technical conference that we've been doing for years and years, and our engineers develop content for that. It's almost like a corporate life cycle. Everything is geared around this big event, and that's gone virtual now. So they're still doing it, but it's going to be online. But the point that I wanted to make is that one of the ways to get deeper on a problem or on a technology is to have to generate instructional content on it. And so what we'll do is we'll take a senior engineer, kind of tailor them or hook them up with a younger engineer, and they'll create some content for this this training environment. This is maybe something that can also be replicated in the curriculum. I mean, if you require students create some sort of instructional material, perhaps as a group, it will kind of force them to get beyond that, first page kind of stuff.
I think one point to make too on this is in the industry that we work in, a lot of the things we're trying to do, nobody's ever done it before. So it's not in a book, it's not on the internet, it's not in any of those places. You use all of those references and you put them together, but then it's you from there on, and you're going to get it wrong, and you're going to, have to try. You can't be set back by the fact that you got it wrong, even though you're working within a timeline and a budget. You have to be able to apply all of those different sources and try something. I get that's very attractive to a lot of people, right? To do something that no one's ever done before, but you're not going to find it anywhere on the internet. You can find people's different versions and people's different failures. You can go in the library and understand the theory. You do have to understand the theory of what you're trying to do if you want to have your best effort at doing the cutting edge. But then it's you after that. And all of these students have to know that we want to hire them for who they are. We don't want them to be a clone of the next guy and the other one. We want to hire them for the different thought that they can bring, and that they do have the structure. They do go into the library. They do learn from those books. They do learn from the internet, and then they bring themselves and they add themselves to it. And if they can do that, then that's what brings the world forward in terms of semiconductors and microelectronics in general.
So I have a question that relates to this general topic in it. It seems that what we're doing in the academy is we're failing to impart critical thinking skills for our students, and which turns out to be actually a difficult thing to assess. It's a labor-intensive thing that if you want to see whether a student really understands something, you take them through a process and watch them work on it. So I'm curious from the point of view of people in industry who are looking at ways of providing lifelong learning for their employees and your colleagues. I mean, clearly what you need to do also, you don't want people just learning this cookbook method to do something, and then I learn another cookbook method. And because you can have these days, you can build a robot or a computer program that will do whatever it is that you can train somebody to do by rote. It's useless. You need them to think critically and creatively. And so what is it that you do to help them do this? And I'll give you a couple of contexts here, which is, I think, things that we ought to be doing in the academy. And one is that we should be giving our students tasks that require them to go to the internet, because we know that's what they're going to do anyway. But to do it critically so that they find something. Now, I've had simple little design tasks that I've given my students. And I've looked, and I know that the first 2 or 3 things that come up in terms of the design that someone is proposing to answer this will not do what I want them to do. But it's ballpark, and they have to go look at it, and they have to modify something in order to make it actually do something. And this would turned out to be a very simple thing, which was just a hardware version of a switch to bouncer, because if you look up switch to bouncers online and you do it, I made them do it with a 555 timer, so it has to be really clumsy and everything. But the very first design that came up, it gave parameters for the capacitance and resistance, and the capacitor was way off. And they had to think about what they were trying to accomplish if they were actually going to make this work. This should be like a 2-hour project. It shouldn't take long to do, but they all started out poorly on it until they thought about what they, and so we can think about a process for having students and new employees and employees at any stage. How do you get even more and more critical? And then a second thing to think about is that that you have a newbie that comes into your office, or we have a new student comes into one of our offices and they say, I can't find anything on this. And you type it into Google and it comes up immediately what you're looking for, because you know the question to ask. And it turns out most of the time it's the literal question they just asked, but they somehow think they have to simplify it in some way or whatever they're doing. And so it's this process of finding the information and then thinking critically about whether this will actually do what they want it to do, or is this just a piece of something and they've got to look for something else. And I'm curious of what training is like in industry in terms of getting to people to do that, other than having a good mentor who just bangs them on the side of the head when they don't do the right thing and move them in a different direction. So.
Yeah, I'll go for, oh, go ahead, Dave.
No, go right ahead.
Thanks for raising the question, Ken. I would say in the programmatic part of kind of ongoing learning is, I guess, an unstated desire to teach the ability to how to pivot. So I think kind of tying to your critical thinking, there's a lot of whether we're improving something or problem solving to X. Is being able to make that change. I think there are two elements into that. Is human nature applies. People don't typically want to come up and say, I've hit a wall, or I'm incorrect or wrong. I think the second is tying back to the opening notion of, again, whether it's on-site, remote, or kind of a combination of hybrid, is that ability to get a little bit deeper in understanding why the need to pivot. So it's designed in our sprint programs, particularly for those who are either interns or newly on board as part of that. So I hope that feedback helps.
Very good. I know that Wilson mentioned earlier that previous discussion about failing early and failing often. So that's you can build more of that into the curriculum where it's okay to fail. I saw an interview with Tesla a while back where I think he only asks 2 questions during his interviews with new candidates. One is, what's your worst failure, and how did it change your career? So that forces a certain amount of criticality. If you're expecting to fail, but now you know that you have to go back and dig out. The other thing that we do, like I was mentioning on this content development that we do, is we vet the content. So we have other engineers criticizing the training modules that are being developed. And so that kind of does 2 things. It gives them that feedback, but it also forces them to do a lot more critical thinking before they send it out to the wolves. So trying to incorporate those kinds of activities in the course material would be great too.
If I could add one item as well, there in industry in general, there's a little bit of natural selection. So the people who do well in their careers are the people who do this critical thinking quite well, and they become your leaders or your mentors within the technical environment. So you can learn by copying those people and working with them directly, whether they're your formal mentor, your department head, whomever it is. But they become successful. We check on a quarterly basis whether people are getting stuff done that they should get done or not. And if they're just not critically thinking, they're not getting it done, and they just don't move up in the organization in terms of achievement. And so you end up having 10, 20, 30 people who are good at that stuff who become the role models for everybody else. It's not exactly what you can do in academia, but you can take people who do that well and copy them. And that's how we get through that problem in the industry in many cases.
Very good. Okay, I think we're at the bottom of the hour now. I want to thank all the panelists. You guys did a great job. Also, thanks for all the comments and questions from the crowd, and hope this brought some value.
Great. Thank you all. Thank you all so very much.
you.
Sure. Welcome back, everybody. I hope you have enjoyed today as much as I did. I thought it was a really great conversation. And the thing that I think struck me the most, and I think was most coherent across the different sessions, was this idea of students owning their own education for the rest of their lives. And Judy and Mark pushed that, as well as many other people. And I think it's kind of fascinating that if you sign up to participate in this industry, you are making a lifelong commitment to being a student, as well as being your own coach and your own educator. And I'm not sure, I'm sure people in other industries would say, oh, yeah, that's true for everybody. And I really don't think it is. I think our environment changes year to year. The tools, the hardware, the software, the customers, the demand is all moving all the time. Just don't think that that is as true in most other industries as it is here. And I think that makes this particular conversation a really interesting and important one. I'd like to thank Mario and Dave for putting together the panels, and also especially Megan and Kim for the orchestration of all of this. It's been extremely helpful putting it together. And remind everybody that we will be back tomorrow with some more good content, and looking forward to seeing everybody.
Thank you, everyone, for the great morning.
Great. Thank you all. We'll see you tomorrow.
Thanks, everybody.
Thanks. Bye-bye.
Bye now.